I want to welcome you all to the Pathology Grand Rounds. We're starting a new year, 2012, and it gives me great pleasure in introducing our speaker today to start the series, Dr. Lorita Rovelletto-Deventi. Okay, her topic is going to be epidemiology of de-novo donor-specific anti-HLA antibodies, the East Carolina University Transplant Study. It's always great when the first slide has a title, makes it easier for me to have to read it. Lorita has no conflicts of interest or conflicts with the data that she's presenting. She received her degree, which actually is a Bachelor of Science from pharmacy school in Brazil. And then she saw the light and decided to come to Greenville, North Carolina to be a graduate. She got a master's here and then a PhD. And Lorita's been here. She's the head of the histocompatibility laboratory. She has a number of publications and presentations, and she's going to give us an update on the epidemiology of the transplant studies here. I want to welcome everyone who's here. Thank you. And remember to fill out your evaluation form again.
Thank you, Dr. Lehman, for that introduction, and welcome to Grand Rounds. What I'd like to do today, I will begin by discussing some data from the U.S. registry on a little bit demographics and survival after kidney transplantation. I'll then briefly discuss the methods that we use in the laboratory to screen and identify for HLA antibody. And then the second part, the last part of the talk, I'll talk a little bit about the our data. So annually, there is a compiled data of all transplants done in the U.S. And that give us an idea how we are doing, what the survival demographics, et cetera, for all types of transplants. Here it's for kidneys. I'll restrict this talk, this portion, just for kidneys because that's the type of transplants that we do here at ECU. Here in this slide, you can see the bars representing the transplants done from 1999 to 2008. So that's a 10-year transplants done in the U.S. You know, the purple portion is the transplants done from deceased donors. And I don't know which color, you can see that blue or light blue, whatever that color might be for you. Those are transplants done from living donors. As you can see, I think 2004 is the year that about 50-50 transplants are done from deceased donors and from, same as done from living donors. And it seems the numbers are a little bit less from the living donors, but that's an important pool of donors that are still done, mainly because as you look at the kidney waiting list, the waiting list really keeps growing at a very much higher rate than the number of patients being transplanted. As you can see, the bars don't look very differently, but the number of patients waiting is really growing very much higher rate. So now in these slides, we're looking at the waiting list. These are all patients waiting for a deceased donor. When we looked at the number of patients waiting 1999 versus 2008, in terms of age of patients on the waiting list, as you can see, there's a big shift, a bigger shift for older patients waiting. So the green portion of the bar, those are patients 50 to 65, and even the dark blue, I'm trying to find my arrow here. Here. Those are greater than 65 years old. That's, again, a much higher proportion. So the waiting list is getting populated with more and more older patients. But the good news is that pretty much the same patients being transplanted are reflecting the waiting list, which is good. So now, this is the only graph that I was talking about survival. This is the 3 months, 1 year, 5 years, and 10-year survival. The 5-year patient survival percentages based on transplants from 2002 to 2007. and the 10-year patient survival based on transplants during 1997 to 2007. And as you can see there, I will briefly explain the types of deceased donor, the non-expanded criteria donor, and the expanded criteria donor. The expanded criteria donor are those donors who are older, greater than 60 years old if they are healthy. However, one can be considered an expanded donor if they are greater than 50 years old and if they have a history of hypertension. The cause of death is a stroke and or creatinine greater than 1.5 at the time of brain death. So those are perhaps higher risk donors. Then obviously the ideal donor is the living donor because you can, those donors are carefully tested, screened, make sure they are healthy, and they tend to be perhaps a little younger, not sure that, but at least they are healthy. And when we transplant from deceased donors, often some of the histories get missed, but for many patients that's a life-saving organ, so obviously we take it, do the best we can. But looking at the 1-year survival for either one, the living donor and deceased donor, it looks very good, approaching 100% or greater than 90%. As you can see, as we 5 years and 10 years, obviously recipients of living donors have much better survival than those receiving organs from a deceased donor, particularly the expanded criteria donor. So I guess the point I want to make here is that by 10 years, the majority of patients have lost their grafts. So really, a transplant is something that, especially for a younger patient, you expect them to need more than one transplant during their lifetime. And here, just highlighting the, when we look at transplants done 2007 versus 2008, the numbers haven't changed that much. It's not, as I showed you the list, and I have another slide later, is growing. I think that the main, in particular for the kidneys, is lack of donors. The number of donors have not changed that significantly over time. So for the most part, we've done the same, perhaps total, just a few less transplants from 2007 to 2008. And looking at the waiting list, I checked that last week. There are over 100,000, 112,000 patients waiting for a transplant. Majority are waiting for a kidney. And the number of donors hasn't changed that much from that first slide I showed you. So the demand, the need for living donor is very, very great. So our patients who come in with a living donor, they get to be transplanted much quicker. And our average waiting time, it used to be 5 years, perhaps a bit lower now. So especially for all recipients, they will wait 4 to 5 years before they come up on the list for a deceased donor. And I won't elaborate too much on that, but obviously depends on the ABO. Sensitized patients, patients have antibodies to many potential donors are going to wait longer. And I'll elaborate on the antibody in just a little bit more. So in the laboratory, perhaps it's a good time to mention how do we become sensitized to HLA antigens? Obviously previously transplant individuals often come back with antibodies, not only to the mismatched antigens, but to many other antigens because many HLA molecules share sequences. So one single mismatch could elicit many antibodies because different antigens sharing those particular sequences. So transplant pregnancy women are high risk to become sensitized to the father HLA antigens given to the baby. So women, high risk. Transfusions, although much less because we are currently using a lot of leukoreduced units, but it's particularly patients who have been previously, like women, at blood transfusion, even from a leukoreduced unit, might elicit an antibody response. Those fewer those few cells left over in that red cell bag, it's enough to cause, to raise antibody, not all patients, but in particular those who were previously sensitized. I mentioned those 3 ways, but then there is what has been recently described natural HLA antibodies. This was a recent study that was published, and we see that often in our non-sensitized, particularly male population, they have antibodies. Cannot explain what it comes from. Often patients have never been transfused. It makes you wonder, where do these antibodies come from? The thinking is that those, whatever you want to call natural HLA antibodies, could be a result of cross-reactivities to pathogens, to foods, or don't know for sure. We know that some patients will have those antibodies. Don't know where they come from exactly, cross-reactivities to, I would say probably pathogens makes more sense, but don't know. So a lot of patients will have antibodies. So our job in the laboratory, we do quite a bit of work looking for antibodies. Once the patients come in, obviously we do tissue typing. We don't know the HLA typing of the recipient, so we can list them in the UNOS waiting list. But we do a lot of work trying to identify and characterize the HLA antibodies present in their serum. Until recently, it was a huge job. It was very hard before this solid phase assay became available. We had to rely on live cells, panel of lymphocytes from donors. We tried to get panels of cells covering the most common HLA types. And as you can imagine, the challenges there are, if you're testing with a cell, there are so many antigens on a cell, but also there are so many HLA antigens, 2A's, 2B's, 2C's. It makes it really, really hard to identify the whole spectrum of antibody. Can you imagine using just cells? Thankfully, that has changed because we have way better tools today. So the techniques that are available, and now laboratories are obligated to use a solid phase assay to identify HLA antibodies. So what is a solid phase assay? That's a system that utilize immobilized HLA antigens. Today, most of the products have that, and obviously that's, you're testing for HLA antibodies, no other antigens. And then you just use a secondary antibody as a readout. Some of the methods, assay formats out there, you can use an ELISA, and I'll go into that in just a minute, and some other indirect immunofluorescent assays, using the flow cytometer or luminometer. Luminex, that's what we're using, and I'll show you. You can also use the chip technology. ELISA, I'm sure many of you are familiar. When ELISA first came out, it was a huge, it's like a huge change from using cell trace. It really was a huge improvement from the cytotoxicity cell trace to an ELISA. So the trace come with purified, immobilized HLA antigens on the bottom. Then we had patient serum. You have the substrate. You see color changes. You measure color, and you associate it with a particular specificity in a given well. It became a problem for highly sensitized patients, how the trays were formatted. For HLA class 1 antigens, the companies provided it with single antigens, so a single HLA in each well. So that was a huge improvement. But for class 2, those trays never became available because they switched to the Luminex technology. So they're using all their antigens to coat beads rather than an ELISA tray. So that became a problem. So when finally, a few years ago, we were able to get the Luminex. Here, just a slide showing using an indirect immunofluorescence assay, which essentially beads are coated with HLA antigens. Then you add the patient antibody. You wash, you add a secondary antibody with a fluorescent tag, and you read in the flow cytometer. What we use in the lab, and a lot of labs use, is the Luminex technology, which is a multi-array using three-color immunofluorescence. Essentially, the principle of the Luminex technology, so beads are dual color beads. Each bead is made of a different ratio of 2 colors. So each bead has a unique color profile. And the beads that we use in the lab, they have single antigen on it. So essentially, the machine that we have can sort it out. It's made of to identify 100 different beads. So each bead has a different antigen on it. So we can appreciate the entire antibody profile of a patient using this, all in a tube, 100 different beads. We incubate with the patient's serum, do washes, and then come back with a secondary antibody against IgG, and then you put in the machine, the Luminex. And this is doing some analysis. This is what we see. The computer displays on the y-axis is the intensity of fluorescence intensities, the MFIs, mean fluorescence intensities. And I don't expect you to see, but each little bar indicates the reactivity with each different beads. Each different beads having different antigen on it. And that's now it becomes the tricky part is to what do you use as cutoff. Different laboratories throughout the U.S. use different cutoffs to assigning antibodies. But beside the point, as you can see here, that the intensity of each peak indicates how strong is the antibody reacting to the beads, the first bead. As you can see, all of them have different alleles of A2. So clearly, this patient have an antibody to A2. I don't know that you can see it, but essentially that's how we interpret. And then we do have a printout. We can have an appreciation for the actual intensity of each peak, if you will. The next few slides I'm going to show you is from a patient that has been recently transplanted. This patient came in with, she had a living donor. Her mother wanted to donate it, be her donor. As you can see, this patient have, this is beads for HLA class 1. She has quite a few antibodies to HLA class 1. And this is what we see, the intensity, the raw data versus the normalized data, which subtracts the background for each bead. The specificity, and then the allele specificity on the other row. Then class 2, as you can see as well, those higher peaks on the left, those are antibodies she has, and this essentially, those are really, really common antigens. So this patient, and this is the raw data, the intensities. So the antibodies that listed there, all those antibodies that this patient had. So antibodies to A, to B, to C, and to DR. The antibodies listed that gives that patient a calculated PRA of 81%. So what is the calculated PRA? That's what you might hear about. PRA, a patient has a PRA of such. So this is pretty high. The calculated percent reactive antibody estimate is the percentage of donors that will be incompatible with the candidate based on the candidate's unacceptable antigen. So if this patient were to be listed in the UNAS list, we will list all those antigens as unacceptable. So as donor become available, this patient wouldn't come up, obviously, because patients with, as donor become available, antigens of this patient wouldn't come up with any donor that will have any of these antigens. Does it make sense? I hope I didn't make it complicated explaining that. But this, the CPRA, where did these numbers come from? Those are really based on the actual frequency of those antigens in the population, the donor population in the US. So it's actually based on the actual frequency. So it's pretty good estimate that this patient will be cross-matching positive with about 81% of all the donors in the US. As it turns out, this patient actually was enabled. I don't know, some of you may have seen in the news recently where we did early December the first three-way exchange in North Carolina. The patient that I just showed you, her sera is this one, Stephanie. This is her mom. Her mom wanted to donate it to her, but she couldn't. Mom had one of those antigens that she had an antibody to. As it turned out, they were the drivers. Dr. Hall is there. I'm sure he can elaborate more later. Those two were the drivers of, we kept looking and see if we could swap. As it turns out, this young man here wanted to donate to his mom, and they couldn't. Mom has an antibody against his, probably through pregnancy. And this young man ended up being the donor for her. It was really great. There was no class 2 mismatches between them. So this three-way exchange took place. And that was really an emotional to be there when the donors met the recipients. At the time, the donors, none of the donors knew who they had given. They knew they were giving to somebody else other than intended recipient. So that was kind of a happy, very happy story that enable a living donor transplant, really. Hopefully these patients will have a very long survival. So that was pretty. So as I showed you, antibody really, we do quite a bit of work in the laboratory, identify antibodies and try to make sure that all the potential donors are compatible, listing them unacceptable in UNet computer. So now what I'm going to finish my talking to you is this study that we started a long time ago, 1999. We talked a lot about antibody pre-transplant, obviously plays a huge role determining who gets an organ or not. The thinking at the time were 1999, the tools we have today, they were just in its infancy. We had no access to really all those solid phase assays, and they are not really widespread use as they are today. But the thinking is that if the patient has preformed antibodies, it really determines whether it gets a transplant or not. And it's a measure of preformed immunity. What happened post-transplant when the patient makes an antibody that's donor-specific post-transplant? It was a no-brainer to assume that perhaps it would make a difference and perhaps it would play a role in survival. So what I'm going to present today is the results of this study I presented at a national meeting in October at the American Society of Histocompatibility meeting. Defined incidence and risk from donor-specific antibody based on a prospective 10-year longitudinal study of consecutive renal transplants. So what's in the literature, the current donor-specific HLA antibody literature? Most of the data out there is from single center, but it uses single time points, only one sera. Or if it's a single center short-term longitudinal studies, only looking at 1 year post-transplant. Really, the most data that's out there is using large multi-center international workshop studies. But again, it also has used primarily one sera, 6 months maybe. I think one of the earlier workshops focus on taking a sera at 6 months post-transplant. So in order to determine what's the natural history of anti-HLA donor-specific antibody in transplant. So in order to do that, you have to have a prospective study using all transplants, longitudinally follow up the patients and collect samples as you go, and obviously follow the patients long-term using standard of care. So our study was the first that's prospective. We have a long-term follow-up, 10 years. We have collected samples all along, consecutive transplants. And how did we test it? We tested for this portion, at this cohort of patients, over 3,000 sera were initially tested using the Luminex, a mixed screen, mixed beads with IEBs with multiple class 1, for instance. And if that's positive, then the specificity is determined using single antigen beads. And the cutoffs used were MFIs greater than 1,000 to identify donor-specific antibodies. And also, you're going to find see one portion that talks about we did isotype IgG subclass studies using exactly the same method, coming back with either an IgG 1, 2, 3, or 4 to determine the isotype of the antibody. So between 1999 and March 2006, this study continues. This study goes on. There were 279 patients that were transplanted. There were some patients that had to be excluded. We excluded patients who were repeat transplants, patients who had a positive antibody pre-transplant. They were not really intentionally, they were probably patients with low-level antibodies, since we didn't have Luminex or more sensitive screening to do, so those are inadvertently transplanted with a weak donor-specific antibody. Obviously, patients, some of them get lost to follow-up, and some die of, for example, heart attack. We lose a lot of patients with cardiac issues. So there were 196 patients that were considered low risk that were part of this study. So when looking at demographics of the patient population, really what stands out is when you look to studies done elsewhere, the large percentage of African American populations in this cohort. This is typical for East Carolina. We do serve a pretty large African American population. Here, looking at, if you were just to plot, doing survival curve of patients who are DSA negative versus DSA positive. DSA positive patients have a 30% risk of graft failure compared to DSA negative patients. However, analysis on this way is not really accurate because DSA may come up at different time points in different patients. In reality, majority of the patients, the DSA comes up early, within the first year. And as you can see, it differs between recipients of living donors versus deceased donors. And the average rate of de-novo donor-specific antibody development is about 4.2% per year. Then we looked at predictors of de-novo donor-specific antibodies, doing univariable and multivariable analysis. The strongest predictor of de-novo DSA were patients that were young, i.e. 18 to 35. Let me put a disclaimer here. We have until, I guess still, we transplanted primarily adults. Now we do have a couple of pediatric nephrologists, and I'm planning to edit the consent form so we can include pediatric patients that we might transplant. But for this portion, actually, so far we only have patients greater than 18 years old, and that's the bulk of, we do very few pediatrics in general. But so young patients are perhaps predisposed to developing DSA, recipients of deceased donor, and DQ mismatches. So then, based on this, we can tell our patients who develop DSA, what's their chances of losing their grafts at 1, 3, and 5 years after developing donor-specific antibody. So after 1 year, the chances of graft failure is about 15%. At 3 years, 30%, and then at 5 years, 43%. Then when we looked at, does it make a difference whether the patient has class 1 versus class 2 antibodies? It really is not statistically significant. This slide shows in the y-axis the mean fluorescence intensity of the initial DSA, i.e. how strong is the antibody. And then in the x-axis, the time from DSA appearance to failure or follow-up. And then we have, I hope you can see this in color again, the white circles. Those are patients, they have functioning grafts versus the purple circles, patients who lost the graft. And then the blue triangle, those are patients that the DSA was an IgG3. As you can see here, it looks that whether the patient had a weak versus a strong antibody really did not make a big difference, except that the very low DSA, it looks that that's patients, all of them remain functioning grafts. So very weak DSA perhaps is not. But this is how the analysis was done. We capture all patients with DSA above 1,000. But the interesting thing here that to be noted is that the patients who lost their grafts, the majority of them had an IgG3 DSA. And if you plotted IgG3 negative versus IgG3 positive DSA, there was a statistically significance between those two groups. So IgG3 really was associated with poor survival. And just so we don't wait for discussion, we go right at it, perhaps speculating why is the IgG3 is more deleterious antibody. In this table, highlighting is perhaps a couple of things that I think might be important, is that the longer, perhaps the IgG3 has longer distance between Fc and the Fab, and it makes it more readily available for binding of C1q in comparisons with its binding to IgG1. So IgG3 being a pretty good complement fixing antibody. And it's responsible for mostly to protein antigens. And then this slide compares the all 4 types of IgG. IgG1, as we know, is the most prevalent in, IgG1 being the most prevalent in the serum, followed by IgG2, 3, and then 4. As we just saw in the previous slide, IgG3 being the most able of fixing complement, and then both IgG1 and IgG3 are very good Fc receptor binding. Then looking at the types of DSA that a patient might have. Some patients might have a DSA comes up and might come down, come back again, so the transient one versus those who stay stable, those who might increase over time. And again, I think probably we have, it's just small data amongst the 3 types, really there was not a statistical difference in terms of survival, whether they have one type or another. Then this is very interesting. When we looked at serum creatinine at the time of DSA detection or appearance, very interestingly, patients who develop DSA but have a very normal renal function, it seems that DSA is not deleterious, at least for the time that we follow, as opposed to patients who develop an antibody and their renal function is already compromised. It seems that those patients' survival is much worse, as you can see here, particularly this group. And our data really goes along with data that has been collected from previous international workshop, which has very, very similar results, pretty interesting. So patients with normal renal function, they do not much significantly here, as opposed to patients with renal function that's already compromised. A DSA seems to make it worse. And we looked at other variables as well. So as I showed you the IgG3 data, whether the antibody persisted, whether the patient developed a new DSA after the initial one. We also looked at MICA. MICA is stands for MHC class 1 chain-related protein. It's a very polymorphic system. It's considered a minor antigen, but since it's very polymorphic, and it's very, there's been some studies out there showing that patients with that develop recipients that receive an organ from a HLA identical sibling, for example, often will make an antibody to no-HLA antigens, MICA being one of them. We looked at acute rejections pre and post DSA and serum creatinine at the time of DSA appearance, and I show you that data. So when we looked at, we did an univariate and multivariate analysis. So the IgG3, acute rejection after DSA, and serum creatinine greater than 2.3 at the time of DSA detection were strong predictors. When we look at multivariate analysis, only acute rejection after DSA and serum creatinine greater than 2.3 were predictors. So in conclusions, deceased donor transplants, DQ mismatches, and young age predispose low-risk patients to DSA development. Low-risk patients develop DSA at a higher rate during the first year and at an annual average rate of 4.2%. In this low-risk patient population who become donor-specific antibody positive, their predicted loss rate is 15% 1 year, 30% at 3 years, and 4.3% at 5 years. DSA patients at highest risk are the following: patients who have an IgG3 subclass positive, patients who develop an acute rejection after DSA appearance, and also patients with a serum creatinine above 2.3 at the time of DSA detection. Also, patients might be at risk, those who, again, have an IgG3 subclass positive, patients with a serum creatinine between 1.6 and 2.3. We are, obviously this is an ongoing study. We have some additional things that we're going to look at it. We're currently looking at making aliquots of DNA from donor recipient. We want to do allele level, HLA allele level typing. We want to look at MICA, like I mentioned, MICA antibody testing, and in order to interpret whether the antibody that we detect in the serum is donor specific, we need to do the typing of donor recipient. We're planning to do that. We're going to look at the KIR, or killer cell immunoglobulin-like receptors. And those are very important in NK, or natural killer cell activation. These receptors really, on NK cells, they talk to, or they communicate, they engage the MHC of cells of your body to allow NK cells to become activated or not. So we're going to look at that to see if those the KIR genes are compatible, the gene profile of the recipient versus donors, and see how that plays a role in survival. That's a very exciting study. We're also going to look at the angiotensin type 1 receptor antibodies. But I have to say, all this study was really possible because of a collaboration that we have, ongoing collaboration with Dr. Terasaki. So I have to acknowledge that collaboration that really has allowed a lot of the studies to occur. But within our institution, many people have helped. I have many people to thank here at East Carolina PCMH. Kim Briley has been with me working in this project since 2001. She goes to clinics, consent to patients. She processes many samples. She does some testing. She keeps up with the database, patient data. So she's really key to the study. Mamie, upstairs in the faculty support area, she sends quarterly letters to the patients. That's how we get samples to come in on a routine basis. We send them a letter to remind them to please, when you go have your routine labs, take this letter, have them send an extra tube of blood for the study. Many people, including Dr. Balance, let us use his courier. So, patients are in outlying hospitals. We get samples sent in all the time. LabCorp, Eastern Nephrology, patients come in, they call, we go pick up samples. So we have a lot of people to thank for it. And of course, the most important people, the people who are really taking care of the patients. So our clinical patients taking care of patients allow our great survival and supportive of the studies. So thank you. And I'll be happy to answer any question that you might have.